Okay, so let's take a look at another question from the topic of electromagnetism. Here we are asked, how is the ampere defined? So this question is about the definition of the electrical unit, the ampere. Well, we actually have a very specific definition. This is the 1946 definition, or a slight variant of it. The constant current, which if maintained in two straight parallel conductors of infinite length of negligible circular cross-section and placed 1 meter apart in vacuum, would produce between these conductors a force equal to 2 times 10 to the minus 7 newtons per meters of length. Okay, so two long conductors which are parallel, they are 1 meter apart, and then the ampere is defined as the unit of current running through which would produce a force on the other one per unit length of 2 times 10 to the minus 7 newtons per meter. So we have a formula for calculating force per unit length. We know force per unit length is equal to mu naught over 2 pi multiplied by current 1 times current 2 divided by the distance between the two. Now in this example, this ampere current, this is going to be the current in both of the wires. So I1 is going to equal I2. This will be I1, this will be I2. Mu naught we know to be 4 pi times 10 to the minus 7. So I1 is equal to I2, R is equal to 1. So the force per unit length, we were told, has to be 2 times 10 to the minus 7. So this gives us 2 times 10 to the minus 7 has to be equal to mu naught, which is 4 pi times 10 to the minus 7 divided by 2 pi times I1 squared over 1. These 2's simplify, these pi's cancel. This gives us 2 times 10 to the minus 7 is equal to 2 times 10 to the minus 7 times I1 squared. Well, this implies that I1 squared is 1. This implies that I1 is plus minus 1. And consequently I2 is plus minus 1 as well. So we're getting I1 is equal to 1. This is 1 amp, right? This is the mathematical definition of an ampere. An ampere is a unit of current which occurs in a single variant of the unit under this circumstance.